Imagine this. October 2017. Astronomers at Haleakala Observatory spot a faint streak of light moving across the sky, a visitor from the stars. Within days, it becomes clear this object isn't from our solar system. It's the first interstellar traveler ever detected, a cosmic messenger from the deep unknown. We called it Oumuamua, Hawaiian for a scout, a messenger from afar. But what it did next would haunt astronomy for years to come. Oumuamua wasn't round like a comet nor rocky like an asteroid. It was long 10 times longer than it was wide-shaped like a cosmic cigar tumbling through the void. As sunlight hit its surface, it reflected like polished metal. But when scientists tracked its trajectory, the data made no sense. It was accelerating away from the sun, with no jets of gas, no outgassing tail, no visible propulsion of any kind. That single anomaly shattered the quiet confidence of celestial mechanics. The object's ghostly green halo could, in this interpretation, be ionized plasma, the exhaust of an unfamiliar technology. But that explanation leads to an even more daunting problem: energy. To alter the velocity of a multi-trillion-kilogram object by even a fraction of a kilometer per second requires continuous thrust for days, perhaps months, powered by energy sources far beyond anything humanity can currently sustain in deep space. Hypothesis 3. Gravitational mastery. And so the debate raged. Was it an icy shard from a dying planet? Or something far more deliberate? But here's the question that refuses to fade. What if Avi was right? What if, 8 years ago, we were staring at the first evidence of interstellar engineering, and we simply weren't ready to see it? Because today, in 2025, another visitor has arrived. It's brighter, stranger, and infinitely more deliberate than Oumuamua ever was. We call it 3I Atlas. And if Oumuamua was a whisper from the stars, Atlas might be the reply. "8 years after Oumuamua slipped silently into the darkness, the cosmos has sent us another message. In July 2025, astronomers scanning the night sky noticed a faint emerald speck moving against the backdrop of distant stars. At first, it was just a whisper on the detectors barely distinguishable from background noise. But within weeks, that whisper became a shout. The object brightened, flared, and revealed a trajectory that defied every expectation. They called it 3I Atlas, the third confirmed interstellar visitor ever to cross into our solar system. Its path came not from the familiar gravitational family of our planets, but from the cold, silent gulf between stars, an emissary from deep space. At first, scientists expected another Oumuamua, fast, strange, but still obeying the classical laws of motion. Yet this one refused to follow the script. As it approached the sun, its velocity began to decrease, not by much fractions of a kilometer per second, but enough to ignite a scientific firestorm. You see, natural comets accelerate as they draw near the Sunday radiation pressure, and outgassing act like a rocket engine, pushing them faster and faster along their orbits. But 3I Atlas was slowing down. It wasn't just drifting, it was braking. Within days, observatories around the world confirmed the impossible. The James Webb Space Telescope measured subtle shifts in its spectral lines. Radar stations in Chile and Australia triangulated its path. Mars orbiters detected Doppler deviations that no atmospheric interference could explain. Every dataset told the same story. Atlas was shedding velocity, as though something or someone were easing it into place. For the first time, the scientific community confronted a possibility too uncomfortable to name aloud. Could this object be under control? Unlike Oumuamua, which fled the sun as if in haste, 3I Atlas seems to have arrived with intent. It's not racing through our solar system. It's taking its time, almost as if it wants to stay. And that, perhaps, is the most unsettling part of all. In science, there are moments when data do not merely surprise us, they defy the universe we thought we understood. 3 Atlas has just created one of those moments. According to Newton's laws, celestial objects obey an elegant symmetry. As a comet approaches the sun, gravity pulls it inward, and radiation pressure, the steady push of sunlight, drives it faster along its orbit. Every comet ever observed accelerates as it nears the star at the center of our solar system. It's as predictable as sunrise itself. But Atlas isn't following that script. Between September 23rd and 26th, its velocity relative to the sun dropped from 68.2 to 67.9 kilometers per second. That's a mere 0.3 of a kilometer per second, an almost imperceptible nudge, yet in astrophysical terms, it's a revelation bordering on heresy. To understand why, imagine trying to stop a freight train with a feather. The energy required to slow an object of 70 trillion kilograms, hurtling through interplanetary space, is astronomical. There is no known natural mechanism that can produce sustained deceleration in a body moving through the vacuum of space. Outgassing from sublimating ice can accelerate an object, yes, but never break it. Gravity only pulls things faster. Radiation pressure only pushes them outward. And yet, every instrument agrees. The James Webb Space Telescope recorded consistent Doppler shifts. Ground-based radar arrays in Chile and Australia confirmed the same pattern. Even orbital spectrographs on Mars registered matching velocity drops across multiple independent measurements, spanning days, across millions of kilometers. This isn't noise, it's a signal, a deliberate one. Some physicists now whisper the unthinkable. Could Atlas be actively controlling its motion? The data hint at micro-adjustments, like the gentle braking of a craft entering a stable orbit rather than plunging recklessly through. If this deceleration continues as it nears the sun, the laws of celestial mechanics will need rewriting, and perhaps, more disturbingly, we'll have to confront an even greater rewrite not of equations, but of our assumptions about who or what might share this galaxy with us. Because what's slowing 3I Atlas may not be physics. It may be intent. When confronted with an anomaly that violates the laws of physics, science does what it has always done: it imagines. In the case of 3I Atlas, that imagination has produced three competing hypotheses, each more unsettling than the last. Hypothesis 1. The reverse solar sail. Imagine a sail, not on a ship, but in space, shimmering under the relentless pressure of sunlight. A conventional solar sail accelerates away from a star, pushed by photons, like wind filling a canvas. But what if you turned the sail around? What if you angled it just so, transforming it from an engine of propulsion into a cosmic parachute? In theory, a sufficiently reflective structure could use solar radiation to brake instead of speed up. And here's where things grow eerie. Spectroscopic data reveal Atlas's surface reflects light with metallic precision, brighter than any natural comet nucleus ever recorded. Yet, despite its spin, it maintains a stable orientation relative to the sun, as if deliberately positioned. Natural objects tumble. This one seems to steer. Hypothesis 2. Hidden propulsion. If Atlas is not using light to brake, perhaps it's using power. Some researchers suggest undetectable electromagnetic or ion propulsion engines, so subtle, their emissions lie below our current detection thresholds. The object's ghostly green halo could, in this interpretation, be ionized plasma, the exhaust of an unfamiliar technology. But that explanation leads to an even more daunting problem: energy. To alter the velocity of a multi-trillion kilogram object by even a fraction of a kilometer per second requires continuous thrust for days, perhaps months, powered by energy sources far beyond anything humanity can currently sustain in deep space. Hypothesis 3. Gravitational mastery. Then there is the most audacious idea of all, that Atlas is manipulating gravity itself. By timing its flybys of Mars, Venus, and soon Jupiter with uncanny precision, it could be using planetary encounters to adjust its trajectory, not randomly, but intentionally. Statistically, the odds of these alignments occurring by chance are less than 1 in 50,000. To guide a path through the solar system with such perfection suggests not chance, but choreography. Each of these possibilities, reflective control, hidden propulsion, or gravitational mastery, challenges the boundary between natural phenomena and technological intent. None provide comfort, because if even one is true, then Atlas isn't just visiting our solar system, it's navigating it. And that realization forces us to ask the most haunting question of all. If it is steering, who or what is holding the helm? When we map the lineage of interstellar visitors, a haunting pattern begins to emerge, one that suggests the universe may be watching us back. The first emissary, Oumuamua, arrived in 2017, a slender shard tumbling chaotically through the void. It accelerated, yes, but outward, away from the sun, in line with the radiation pressure we already understood. The anomaly was its cause, not its direction. It came and went swiftly, a cosmic ghost crossing our field of vision for only 11 days. It left us puzzled but still secure in our physics. 2 years later came Borisov, the second interstellar traveler. It was faster, bluer, and brighter but comfortingly familiar. Its composition, rich in water and cyanide, placed it firmly in the realm of natural comets. It reassured us, interstellar space still obeyed the same laws, even if its chemistry differed slightly. But in 2025, with the arrival of 3I Atlas, that sense of reassurance collapsed. Atlas does not behave like an interstellar stone flung randomly through the galaxy. It behaves like an object with intent. Its surface gleams like polished chrome, unnaturally reflective. Its gaseous halo, instead of being driven by water vapor, consists of an unprecedented 95% carbon dioxide, a chemistry alien to every comet cataloged in human history. And when scientists calculated its density, the numbers made no sense. Too light for its size, suggesting a hollow interior, perhaps even a structured one. But the most alarming pattern is not chemical, it is behavioral. Oumuamua accelerated. Atlas Decelerates. The first came and left in haste, as if avoiding detection. The second lingers, maneuvering delicately through gravitational corridors, threading the orbits of Mars, Venus, and soon Jupiter with timing so precise it borders on mathematical perfection. If this is coincidence, then the cosmos has a sense of irony. If not, then we are witnessing an escalation. Where Oumuamua tested our instruments, Atlas seems to be testing our understanding. One revealed the limits of our observation, the other probes the limits of our imagination. The message, if there is one, grows louder with each visitor. We are not alone in this cosmic conversation. Dr. Avi Loeb, once ridiculed for suggesting that Oumuamua might be artificial, now concedes something extraordinary. Compared to Atlas, he says, his earlier hypothesis looks conservative. His team's probabilistic model places the likelihood of natural origin for Atlas at below 40% and falling. For centuries, we've stared into the night sky, wondering if anyone was out there. Perhaps we've been asking the wrong question. The real question may not be whether they exist, but when they chose to reveal themselves. Because, Oumuamua whispered. Atlas, on the other hand, seems to be speaking clearly. And maybe, just maybe, it's waiting to see if humanity is finally ready to listen. Every scientific mystery eventually faces a moment of reckoning, a test where the universe itself delivers the verdict. For 3I Atlas, that moment is now only days away. Between October 29th and 31st, Atlas will reach its perihelion, its closest approach to the Sun, just 1.36 astronomical units, slightly inside the orbit of Mars. In this window of fire and radiation, the laws of physics become merciless judges. Any natural comet exposed to such intense solar heating would face the same fate, fragmentation or vaporization. Its icy core would boil from within, internal pressures ripping it apart in a spectacular death spiral of dust and gas. But what if Atlas refuses to die? Astronomers across the globe are preparing for what some are calling the most important observation campaign in human history. The James Webb Space Telescope will monitor its infrared signature, searching for structural breakup or temperature anomalies. The European Space Agency's solar orbiter will attempt direct imaging of its corona, while ground-based observatories from Hawaii to Chile will track its velocity through Doppler shifts accurate to 1 part in 10 billion. The stakes are cosmic in scope. 3 distinct outcomes could redefine our place in the universe. Scenario 1. Fragmentation. Every scientific mystery eventually faces a moment of reckoning, a test where the universe itself delivers the verdict. For 3I Atlas, that moment is now only days away. Between October 29th and 31st, Atlas will reach its perihelion, its closest approach to the Sun, just 1.36 astronomical units, slightly inside the orbit of Mars. In this window of fire and radiation, the laws of physics become merciless judges. Radar stations in Chile and Australia triangulated its path. Mars orbiters detected Doppler deviations that no atmospheric interference could explain. Every dataset told the same story. Atlas was shedding velocity, as though something or someone were easing it into place. Atlas disintegrates under solar pressure, its nucleus shattered, its mystery reduced to chemistry. Humanity exhales, comforted by natural explanations. The universe returns to its familiar indifference. Scenario 2. Survival. Against all expectations, Atlas emerges, intact, its structure unmelted, unbroken, its reflective surface still gleaming like a mirror. Such endurance under solar stress would imply internal reinforcement, perhaps a hollow engineered shell. But if it holds together, or worse, adjusts its trajectory deliberately, then October 29th will be remembered as the day human history crossed a threshold. Because when an object from another star resists the Sun itself, it's no longer a comet we're studying. It's a presence. And this time, the question isn't whether we can see it. It's whether it is watching us. When Galileo first pointed his telescope at the heavens, humanity crossed an invisible boundary from believing the universe revolved around us to realizing we were just one world among billions. Today, 3I Atlas may be forcing us across another boundary entirely, from asking if we are alone to wondering who might be watching us. Because Atlas is not behaving like a comet on a transient journey. It is behaving like a sentinel. Its deceleration, those gentle braking events so meticulously measured, may not be random anomalies, but deliberate corrections. In orbital mechanics, such maneuvers are used by spacecraft to stabilize trajectories or establish long-term observation points. And that is precisely what some scientists now suspect. That Atlas may be establishing a station within our solar system. Think about that. For billions of years, the Sun has drawn dust and ice inward, flinging them back into the darkness. Nothing lingers, everything moves on. But this object, from the deep interstellar void, has entered our celestial neighborhood, and instead of fleeing, appears to be slowing down to stay. If that is true, we may be witnessing something extraordinary. A technology actively maneuvering among the planets. Its timing could hardly be more precise. But if it holds together, or worse, adjusts its trajectory deliberately, then October 29th will be remembered as the day human history crossed a threshold. Because when an object from another star resists the Sun itself, it's no longer a comet we're studying. It's a presence. And this time, the question isn't whether we can see it. It's whether it is watching us. The object could be riding the invisible waves of planetary gravity, adjusting itself like a surfer, choosing the perfect wave not for escape, but for observation. If this interpretation is correct, the question becomes chillingly direct. Who is observing whom? To the untrained eye, this might sound like science fiction. But remember, every great leap in human understanding once sounded like madness, and perhaps, more disturbingly, we'll have to confront an even greater rewrite, not of equations, but of our assumptions about who or what might share this galaxy with us. Because what's slowing 3I Atlas may not be physics. It may be intent. It's behaving like a resident, deliberate, patient observant. And if that's true, then somewhere out there, among the stars, someone designed it to be exactly that. The only real mystery left is why. And maybe, just maybe, that answer is already being written silently in the light it reflects back toward us. For centuries, humanity has stared into the night sky asking one question: are we alone? But perhaps we've been asking the wrong question all along. The real question is this: if someone out there finally answered, would we recognize it? Because 3I Atlas may not be just a comet or a fragment of ice drifting through the void. It may be something far more deliberate: a probe, a messenger, or even a test. And the most unsettling possibility is that it isn't here by accident, but by design. Think about it. If Atlas is slowing down intentionally, what is its purpose? Observation? Data collection? A signal waiting for a civilization advanced enough to notice its impossible behavior? Or could it be something more profound, a scientific experiment conducted not by us, but on us? And what if this isn't its first visit? What if Earth has been under quiet observation for centuries, but only now do we possess the instruments and the humility to detect it? Physics tells us what should happen, but the cosmos has always delighted in breaking its own rules. Each time we believed we'd reached the limits of understanding, the universe whispered, "Not yet." So here we stand, on the edge of discovery or delusion, staring into a mirror held up by the stars themselves. 3I Atlas forces us to confront a truth as old as curiosity itself. The boundaries of science are not drawn by the universe, they are drawn by our imagination. Could this be the dawn of first contact, not in words or signals, but through physics itself? Could this object be the universe's way of asking us the same question we've been asking it for centuries? And if that's true, are we brave enough to answer? If you followed this far, then you're part of this unfolding mystery. Subscribe to stay with me through the Perihelion passage of 3I Atlas. 8 years after Oumuamua slipped silently into the darkness, the cosmos has sent us another message. In July 2025, astronomers scanning the night sky noticed a faint emerald speck moving against the backdrop of distant stars. At first, it was just a whisper on the detectors, barely distinguishable from background noise. But within weeks, that whisper became a shout. The object brightened, flared, and revealed a trajectory that defied every expectation.